All right, kids, you're running out of shopping time here. It's this 14th of December. I know, I can't even get my head around that idea. So listen, this isn't really anything extraordinary. I maintain this should, unless things go off the rails, and sometimes they do, this should be a relatively quick lecture. So what we're doing is just systems today with missing variables. And again, if I do my job well and you listen and understand well, then you'll walk away from this and say, yeah, he's right. This is actually a good thing. But if I just threw it at you, then all want to know, what do I do? There's like, this one doesn't have a Z or something like that. And that's actually great news. So these are triple systems, triple 3x3. I sometimes just call them triple systems with missing variable. There are instances in which things can get a bit confusing and more complex. And once you get really confident and good at the process of solving a triple system, you just start to find workarounds. And at first, when you learn a topic, it's intimidating and you're worried about, it's like driving, you're worried about every little thing. And then eventually when you become natural at it, you start to just inevitably evolve into something better. And that's kind of how it is with these. And a lot of you are already at that point where this is just like meh. So if you ever encounter things that don't fit into the mold of what we've done or what we learned today, just try to think creatively, work around. But today's are all sort of cut from the same cloth. So today's will have one missing variable, not multiples. So let's just, and again, I only have one example because I don't think this is going to take anymore. So we're going to do 3x plus 5y plus 4z equals -3. And then our second row, or second equation is going to be -2x minus 6y plus 3z equals -6. And then our last row is 4x plus 7y equals -3. You can see that it's inescapable, almost inescapable, that if I just gave you this assignment and said, here's some more systems, that you'd be well within your normal rights to say, what is this a typo, right? Because what we're used to is we have x, y, z, x, y, z, like every row has x, y, z. So this is actually great news. So you just have to see it from the right perspective. The great news here is that someone has already made a decision for us. Whoever wrote this, well, it was me. I guess I did that. I wrote the problem. So I have already kind of given you the guidance and the direction. Here's what you need to know about this, is that you don't go into a problem like this saying which variable looks like it would be the easiest to kill. What choice has already been made for you? Right. So what's happening here, and you do run out of resources, so that's where the workarounds and the getting creative start to come in. If you're not careful, you can run yourself out of resources. The equations are your resources. And if you don't use them wisely, then you can run out. But thankfully, we have 3 equations, and in the third equation, we're missing a z. So when you think about, remember, big picture on these, we're trying to take a 3x3 and chunk it down to a 2x2. So what I can do right now, and I'm going to try to be as tidy about this, you should as well. One sec, okay, Cooper? What I'm going to try to do right away is I'm going to take this equation right here, and I'm going to move it out of the way. If I can just grab it. I don't know if I can or not, but yeah. I'm going to... Yeah, you can't do that with your pencil. But so, you obviously would just copy it over someplace else. But what you've done now is you've already created 1/2 of your 2x2. And so now you do have precious resources left, and using those resources, you can make another one just like it, right? But again, the choice is not yours. You don't get to look at the x's and say, oh, I want to kill the x's because there's one positive and one negative or something like that. It's not your choice to make at this point, right? Who do we have to kill? Right. So what we basically do is we shrink our triple system down to a funky looking, like non-square system. It's like a 3x2, I think is what you would call that, or something. So we're going to take that little mini system in the upper left-hand corner, and we're going to modify its 2 rows to suit our needs. So the first thing we want to do, Yeah, I mean, honestly, let's have that discussion when we're done and see how we all feel about it. Because I think it like, I don't know. Let me have that. Let's talk in a minute about that. So what I'm going to do is I'm going to be smart about this. You are, and we're going to say, how do we kill the Z's? Well, we want to make them into 12s, obviously. And one of them has to be a negative and one of them has to be a positive. So I'm going to take, which one do you want to multiply by a negative? I don't care. I heard the first one. I heard that first. I will always take the one I hear first. So I'm going to take the first equation and I'm going to multiply it not by 3, but by -3. And then I'm going to take the second equation and I'm going to multiply it by normal +4. And you'll see here in a second that I don't think the R1, R2, R3 notation is going to be necessary just because we've gotten the bonus, and every problem today has this. So like I just made you 4 of the same thing. Like a missing variable, you can take the shorter equation with the missing guy and just pull it off to the side. And then he's really not going to get to play now for the next few minutes. He's like out of the game, right? So when we take these equations and modify them as, per that multiplication, we're going to get a new top row, which is going to be -9x minus 15y minus 12z equals +9. And then our new second row is going to be -8x minus 24y plus 12z equals -24. So, I mean, I don't know what your paper looks like. Maybe I shouldn't have done the little trick where I pulled the thing magically off to the side because I don't know how cluttered yours would look. But at this point, I mean, I'd kind of have to, as your teacher, I'd kind of have to be a moron to not know what you're going to do next, right? So if you didn't have the R1, R2 notation, I think I'd probably be okay because I know exactly where you're headed, right? I don't have to guess, are they using row 1 and row 3? Or I was like, I see clearly what your intentions are. So let's add these together. And let's stick the answer to this addition problem right. So when we add these, we're going to take the answer and we're going to place it right there with its homie, right? And it'll match. It'll complete the 2x2 system that we started. Someone else started. So when we add together, how many x's do we get? Okay, how many y's? They're off by 78 if you say 39. -39 is correct. Yep. So -39y, the z's of course cancel, and then we copy down the equals, and what's 9 plus -24? Good. And look, just like that. And I mean, you can see that would be confusing if you'd never been shown how to do it, but it's actually good news, right? It actually does save us a little bit of work, I think. So now when we add these two new equations together, nothing good's going to happen. So we got to do some prep work. And I showed you how to do this the other day. We're super not comfy with numbers like 4 and 17 and 7 and 39. So what are we thinking here? Multiply them by each other, right? Basically 4 and 17 are like, why don't we just multiply by each other, right? And we're going to get the same answer. We're going to cancel when we're done. So I'm going to take the top row of this little baby system over here, and I'm going to multiply it by, I don't need to do any negatives this time, right? I can take the top row times the 17, and then I can take the bottom row times the 4. And if you're good with your multiplication, you already know what those both equal. But the point was from the beginning that whatever they are, they're going to be the same, right? So what is our new top row? I think you might have skipped the X's there, Sutter. I see your point. Touche. Sutter's like, why would I even write them down if they're just going to cancel out? That's an interesting case. I can't refute that. But as a man of principle, I'm still going to write it. It is indeed 68x. But yeah, you're not wrong. So plus how many y's was it? Okay. So can you guys just do 17 times 7 in your heads? Just do 7 times 10 and 7 times 7 and add them up. 119. And then can you do 17 times -3? -51. Good. So there's equation number one. Now this one's going to be, in theory, easier. I don't know. What's 4 times negative 17? Yeah. Still fixated on that logic bomb that Sutter dropped on me a minute and a half ago. I had a hard time recovering from that one. How about 4 times negative 39? Minus 156 y's. And then 4 times negative 15. Good. X's cancel. How many y's do we get? Thank you for saying negative. Just right out of the gate. You don't know how much I appreciate that. Negative. Let's get that out of the way. And then negative what? Yeah, it's looking like negative 37. And then what's negative 51 minus 60? Negative 111, negative 111. Divide both sides by negative 37. What's y? It's definitely a positive. 3. Have I confused you at all? Like, does this make sense where I'm going? Unless I really messed up the last 5 minutes together, the point I was trying to make is that the 2x2 system is already half built. You just have to build the other half with the 2 full triple equations, right? If you ever encounter a system where there's one, like an X missing from one and a Z missing from the other, then we've got some bigger issues on our hands. We're not going to talk about that. I think we'd have to employ a different method for that, like row reduction or something. So today's will all be sort of like this, like one of the variables will be missing, just one. That's that. So let's make this official so I can end this recording. Let's work our way back up. And so since we know y equals 3, we can take our final answer. I'll put it, I don't know, I'll put it down here in the corner, and I can leave my 3 spaces like this, and I can put 3 smack in the center. And now we have to find which one next. Yeah, X is where the doubles are at. So you got to go to the 2x2, and I'm just gonna, since I got the pen, I'm gonna take that equation that I just circled. It seems the nicest to me. So it's gonna say 4x plus 21, because that's 7 times 3, that's y, equals negative 3. So 4x equals negative 24. So x equals negative 6. So I can stick a negative 6, and then it's time to storm the castle. Right, you're leveled up to your max level here, so it's time to head on in for the boss battle. So you head back to your triple system, putting in a negative 6 and a 3, and you have to. I would use one of the original 3s, like. Remember, there were 3 equations at the beginning. One of them is of no use to us here, I don't think. Right, yeah, no, he was trash. So we need one of these, and I'm going to pick this one. So now that we have a negative 6 and a positive 3, if we rewrite that equation that I just circled in yellow, it'd be negative 18 plus, what was y again? 3. So yeah, so plus 15 plus 4z equals negative 3. What's negative 18 plus 15? Negative 3. So you wind up with this negative 3 plus 4z. And I included this in today's work just because this, I kind of wanted to kill 2 birds with 1 stone here. What happens when you add 3 to both sides? Yeah, you do get a 0. And I just want to make sure we're all clear. Most of you have already conquered this mountain, but I just want to make sure we're clear that when you divide by 4 here, you get 0. And 0 doesn't mean anything like no solution or we've encountered the void. It's just a number. So you just stick 0 in there, right? You're going to get a couple zeros, and let's see. I put zeros as answers in 3 of the 4 problems, so you'll find some zeros. Do you have any questions? All right, I'm going to end the recording now so I can make fun of BB.